Hey guys, okay, now we come to the last part of the paper 2. Okay, section B. Okay, we got a case of a fighter jet. So we got this mess. Sudden increase due to the boosters, the afterburners. So from this time, you can see speed changes from 250 to 400, burning off 8,000 kilograms of fuel. So as it burns off, what changes? That's right, the mass change, right? So when they ask you gain in kinetic energy, okay, the first part is to know what is the kinetic energy formula. This is the kinetic energy. So if there's gain, that means something must have changed. You can see here, the most obvious one is the speed actually changes, but something that is less obvious is, yes, the mass actually changes also. Initially it was 26,000, now it becomes 8,000 kilograms lighter. Okay, so when there's gain in kinetic energy from 7 to 20, that means this, at this speed, this is V, okay, 2, V1. At V2, yes, a higher kinetic energy, not just because of the speed, but also, it's a combination of the speed and the mass, right? So V2, this is M1, okay, so M2 will actually be, okay, so M2 will be 26,000 minus 8,000. Okay, so gain in kinetic energy will simply be how many? Okay, half m2 v2 square minus half m1 v1 square. Okay, so what is m2? So half 26,000 minus 8,000 times what is v2? 400 square minus half. What's m1? There's m1 here, right? So half 26,000 times m1 v1 square. So v1 250 square. That's it. Okay, once you can write this down, okay, you get 2 marks. The third mark will simply be the final answer. Just a matter of punching the calculator. Okay, so 627.5 million joules. Okay, with the correct units because it's energy, right? Okay, so what about part B? B part 1. Okay, they tell you, what do they tell you here? They tell you this, how the thrust increases when the afterburners are activated. So I got afterburner, you got a thrust, 200,000. After that, boom, afterburners activated, suddenly 500,000, right? So from 0 to 7, you got to read the question very carefully. 0 to 7, this portion here. Fighter jet cruises at a speed. So what does it mean by cruising at a speed? Okay, constant speed. Yes, you are right. So if it's constant speed, what is the air resistance? So for it to move at constant speed, I know resultant force equals 0, right? 0 Newton. So for resultant force 0 Newton, if I already have a thrust of 200,000 newtons, what air resistance will give me a resultant force of 200,000? You are right. It has to be 200,000 newtons also, right? So that my resultant force. So you see, this is my fighter jet, right? If a thrust of 200,000, what is my resistance? If my resultant force is 0. So for this to be 0, this must be balanced forces, correct? Okay, excuse my drawing here. Okay. Alright, next, the air resistance of the fighter jet remains the same throughout the 20-second period. So throughout, no change. That means what is the air resistance? This is the air resistance, right? So describe and explain with reference to forces. So you need to talk about forces acting on the fighter jet, the motion of the fighter jet. Okay, so as it moves from 7 to 20, so this stage here, what can you say? If the air resistance is constant, so air resistance constant of 200,000, once it comes here, it will be what kind of forces? What will happen to the forces? So first point, forces are now unbalanced. Okay, why unbalanced? Because 500,000 thrust and 200,000 newtons air resistance, so it becomes unequal, unbalanced, right? So what will this result in? So produces resultant force. Okay. So what will happen to the resultant force? So therefore there will be constant acceleration. Okay, how do I know it's constant acceleration? Because my resultant force is constant also. And what is the value of the resultant force? In this case will be 500,000 minus whatever my air resistance is, which is 200,000. Does this change? Doesn't change, right? Is it? Throughout it's the same. So constant resultant force, if I use F equals ma, if this constant, this must be constant also, right? So constant. Okay, got it? This is a bit abstract. This was one of the worst done questions, but no problem. We just need to, I hope you are able to figure that out right now. Okay, describe one other energy conversion other than kinetic energy. Some of you still gave kinetic energy, yeah? So it's chemical potential energy, you got to spell it out, huh? To sound or thermal energy. Okay, that means from the fuel to or very hot from the afterburners, right? Okay, last question here. Afterburners are now switched off. After 20 seconds, it continues burning more fuel while maintaining the speed. So what is the kinetic energy? Okay, kinetic energy formula half mv squared consists of two things, right? Mass and velocity. So if the kinetic energy remains the same, if the speed remains the same, that means this one's same. What can you say about the mass? As it burns more fuel, the mass will decrease, right? So if this decrease, what can I say about the kinetic energy if the velocity is the same? Mass decrease also. Okay, so explain. So it will the kinetic energy decrease. Why? Because why? Because mass, exactly what I said here. Mass decreases while speed is constant. So Ke from this relationship will decrease. Okay? Alright, hope you enjoyed this video. No problem, don't worry about this. Hope you are doing your corrections right now. Okay, so I'll see you in the next.